exams have been graded, so check out your exam, and on any problem you got wrong, make sure you understand why you got it wrong. I put little notes. Sometimes you might not be able to understand. I might not be able to work backwards for my notes. And then ask. We'll have a break today and after class as well. Either of those times, if you have remaining questions on problems from the exam, ask me individually on that. And we're going to go to the practice quiz for today. We're starting with problem number 3 on this practice quiz, 3A. So let me give you a little bit of time for that. Okay, 20 seconds more. Alright, so this part, divide by 3, divide by 3. And then, what about those? Well, if I did the same thing, just divide them by 3, I'd get x to the 4th over x to the 1st. But that's not the way it works. It works this way. The 4 part is right, but you subtract the exponents here, and you get x to the 9th over here. There's no subtraction in the original problem, but the exponents do get subtracted over here. You get 4x to the 9th. And do part B. $20 seconds more. Okay, the rule here is when it's one power raised to yet another power, power to a power we multiply, and we get x to the 12th power. Alright, so give me a little feedback. Did you need this refresher, or were you all set with this? None didn't need this at all. Or, yeah, this is good to refresh this. Let me know. Okay, there's, Valerie, can't get your voice to log in. And then there's some people, who I've switched up. There was group 3. You have been moved into group 1 because we've had some we've had some people who some attrition, and so some of the groups got small, and so I combined. Group 3 is now in group 1, and I put a little note in your group chat. If you go into your group chat now, you'll find that you're automatically in the right group, in group 1, if you were in group 3. And that there's a message in there from me explaining the situation. Similarly, group 4 was down to just a couple people, and I'm switching you over into group 6. So, please, if you're in group 1 or group 6, please welcome your new group members, and this is the way we'll be from here on. And Valerie, what do you click to hear? I can't answer that. Hopefully you'd be hearing. Yeah, make sure you're in the voice channel. And once in a while Discord just screws up and you have to close out and get back in it. You might have to do something like that. Okay, good. Alright, let's go back. Do part C. 3 plus x squared, get rid of the parentheses. Okay, 20 seconds more. Okay, my first instinct, if I hadn't seen this in a long time, would probably be square this one and square this one. But that's wrong. Squaring means multiply by itself. And to multiply by itself is this. And when you have more than one term in each parenthesis, you have to take this term over to here, this one to here. You're going to get 9 plus 3x. And you might know this as FOIL, plus another 3x. I like to put the like terms right underneath each other. Plus x squared, which is 9 plus 6x plus x squared. Okay. And go to D. 2 to the negative 3 power. Twenty seconds more. Alright, negative exponent. Again, on this one, if it had been a long time since I'd seen this, I would probably do this. But that's wrong. That would be what my instincts would probably tell me to do, but the real answer is bring it to the bottom. Make it a positive exponent. And it's 1/8. Alright. Give me a little feedback on C and D, and if you needed refresher on one or more, let me know which one. Or if both. Or if the refresher was totally not needed, let me know that. Okay, good to know, Jeremy, that you haven't seen it in a while. It might be the case for a number of folks. Okay, we're going to be getting into this kind of stuff today. Alright, go to E. 20 seconds more. Okay, so the most common mistake on this is to bring both of them down. This is not correct. The reason why it's not correct is 3 has its own exponent, positive 1. And so the exponent on the x is negative 2, on the 3 is positive 1. So the 3 stays where it is. The x to the negative 2 comes down, is x to the positive 2. That's the correct answer here if you're rewriting it without negative exponents. And typically we do. We usually don't leave an answer with negative exponents because a lot of people have trouble with negative exponents. So they're more comfortable with 1/8 than 2 to the negative 3. So we give our answer that way rather than with a negative exponent. All right, and then there's fractional exponent. 9 to the 1/2 power. Seconds more. Okay, and if it had been a really long time here, my instinct might well be this. But that is not correct. That would be the answer if it was 9 times 1/2, but it's 9 raised to the 1/2 power. Instead of that, we're going to do this. Turns out the bottom number comes out as the root. Top number stays as the exponent. So it's the square root of 9, which is 3. Okay, give me a little feedback on E and F. And if you really needed the refresher, let me know which one or ones. Okay, so we have 2 functions, f and g. Well, actually, I'm going to skip this one. Well, yeah, we'll come back to this if time permits later on. All right, well, let's go to this one. Here's a graph. Answer these questions from the graph. I think these were homework problems, but it's just I want to reinforce these particular homework ones. Thirty seconds more. Okay, now if we look at this, Let's say the input is 4. The output is -3. This is an x value, or an input, and this is a y value, or an output. Now, what would also be true is f inverse of -3, and this is how inverse functions work. The y goes here, and the x goes here. F inverse of -3 would be 4. So we can think of it this way. Function associates the input with the output. And the inverse function associates the previous output. It says, what was its input? What was the input that gave me an output of -3? It was 4. So it just reverses the role of the x and the y in the inverse function. All right, so with that insight, we'll go back to here. F of 0, this is an x. So what's the output? 3. What's the height when the input is 0? So like the price of the stock on day 0 is $3 a share. Solve f of x equals 0. This is a y, or a height. So what are the x values that are going to give me a height of 0? Well, when x is 2. Input of 2 gives an output of a height of 0. F inverse of 0, remember inverse functions, if this is a graph of f, that would take a y value. So where's the height going to be 0? When the input is 2. Find f, we could say, yeah, equals 2. And we have, now notice, solve f of x equals 0. Let me show you that equation. Let me come down just a touch here. If I put f of x, no, solve f of x equals 0. This tells you f of 2 is equal to 0. That's what this line tells us. And if I did f inverse of both sides, I get these two canceling out. 2 equals f inverse of 0. But that's exactly what I was getting on line 27. Okay. And so the last thing is f inverse of x. Now, although it says an x, it's really a y value from this picture. And when solve this equals this, f inverse, these are x's and y's. So what's when the x is 0, the y is going to be 3. So this one is going to tell us x is 3. The 3y value associated with the 0x value in this picture. Alright, so all 4 of these problems were kind of sophisticated analysis of functions and inverse functions graphically. Tell me, did you get more confused, or did that help straighten things out? Did you have it all beforehand, or was this good to review, to go over this? Give me some feedback. Okay, so for some, that might muddle up the picture. It might be a little too abstract. And it's okay. You can give it time, and it might. But for some, it might add some extra insight. Alright, for the following, evaluate or solve. Assume f is 1 to 1. So f being a 1-to-1 function means it passes a horizontal line test, and do 33 and 34. Ten seconds more. Alright, f inverse of 7, you just reverses, goes back to 6, turns them around. F inverse of 2, it just reverses, sends it around back over to here. And a quick graphical interpretation. What it's saying is this. When the input is 6, the output is 7. Like this. Now, when the output is 7, what's the inverse? Well, if this function had not been a 1-to-1 function, suppose it was like this. So, it does not pass the horizontal line test. Then there would be 2 inputs, an input over here as well, that would have had a height of 6. But since it told you it's 1-to-1, then it can't be like this. It does pass the horizontal line test. So that's why we're just going to say, when the output is 7, the input must have been 6. All right. Give me a little feedback on 33 and 34. All right. Another thing that I have changed up is because we went through the quarter point of the semester, and group leaders and backups got changed slightly. So in group 1, which is now 2 different groups combined, Amari, you are now the group leader. So you are going to be, the first thing everybody does when they come into class every time, you say hi in your group chat so everybody knows who's here. And the group leader says who is the speaker for the day for the group. One of their primary roles. And if you forget to do that, I'll just be calling on you, group leader, if I don't get a response from your group. And group 1 backup is Natalie, and group 2, the leader is now Jeremy, and the backup is Jasmine. So you two have switched for this second quarter of the class. And group 5, Caesar, you're now the group leader, and Abigail, you are the backup. So you two have switched roles. And group 6, which is 2 groups combined, I'm having you are the group leader, a nice Silva Martinez. And the backup is Ariana. All right. And questions. Any leftover homework questions or any questions anybody has up to this point? Okay, if no questions, then let's move on to, notice we're heading way back in the textbook. Chapter 1, Section 2, Exponents and Scientific Notation. And I gave you a refresher on a lot of the basic ideas with the practice quiz. But what happened in the practice quiz, though, is I just kind of said, oh, these are what the rules are. But we didn't go into, well, why is it that way? How come you do it this way? And then we'll get into more of that, and hopefully you get a more intuitive feel for why the rules are the way they are for exponents and scientific notation. And first task is right here. Rules of exponents. So you're going to go into your group chat in a moment, and a third grader insists that x squared times x cubed is x to the sixth. Now this third grader would have probably been me when I was in third grade. Because I remember when I first saw this didn't make any sense to me. And she says what I felt. That there's no addition in this problem. There's multiplication. There's no addition. So you can't possibly be adding the 2 and the 3 together. So she is totally convinced that you're wrong. Because we found that the rule was, you add the exponents and you get x to the 5. But she says it's going to be x to the 6th. So your job is to convince her that she's wrong and that the real answer is x to the 5th, but you've got to just convince her. Now, I want each of you to type something into your group chat how you're going to try to convince her. Now, I'm going to put more weight on arguments, though, that get into a little more depth rather than saying this is just the rule. Just forget everything else and memorize this rule. Because that's what she's struggling with. And that's the kind of thing that I struggled with. If I was told just memorize this rule, but I couldn't understand it, I couldn't memorize it. And so let's try to give her something more than just, well, that's just the way it is, and memorize it. All right. So in your group chats, type that stuff in, but don't hit enter yet. Wait for my cue. Because I want everybody to kind of put something in. And again, if you really can't think of anything, at least type in, I can't think of anything. But it's important to be participating with the group discussion. So type it in, but don't hit enter yet. Okay, go ahead and hit enter and discuss it in your groups for a little bit. Okay, group 1. What do you got?
This is Amari. So the only answer we had was exponents do not follow the same rules of math. Exponents have their own set of rules.
Okay, exponents. Don't. You said don't follow the rules of math.
Yes.
Yeah, they do. They follow the rules of math.
Explain.
Me?
Yeah.
Okay, well, this is how I explained it in Group 6's chat. So, the question is, what is x to the power of 2 times x to the power of 3?
Uh-huh.
Now, if we break this down a little, x to the power of 2 is x times x. And x to the power of 3 is x times x times x. So that would make just one big equation of x times x times x times x times x, which is x to the power of 5.
And then I can see it. I could put dots in between all of these. And then
Yeah,
just
but
assume, but I'm just going to leave the one
you
dot
see now, right?
there. And then
That's how I explained it.
visualizing it, we can see that there are 5 x's. Okay. And this, in fact, this is what did it for me when I first had exponents, and they didn't make any sense at all, and I was super confused. It was once I could visualize it like this, and then I could see what it was. Now, this we can kind of elaborate on now. Exponents don't follow the usual rules of math because there's no addition in this, yet we wind up adding the exponents. It's kind of because exponents are a shortcut for repeated multiplication. And we visualize them to see that rules are being followed. Now, what I had to do, and I remembered this, was I had an exam that I had to do this kind of stuff, and I looked at it and I couldn't tell. Do I add these things or do I multiply? All I remember was I was confused about this. And particularly, we came up with things like this. X to the 1.2 times x to the 2.3. And this one, you can't write out 1.2 x's, and you can't write out 2.3 x's, and you can't. And so what I'd have to do is I'd make the problem simpler, like this, and then I could visualize it, and then the rule made sense, and then I could come back to here and say, all right, this convinces me that I add the exponents, even if I can't visualize them anymore. But I'll go to a simpler problem to remind myself of the rule, and then this becomes 3.5, like this. All right. Any questions on this? Because this is a big deal. And in fact, it turns out that although I really was struggling with exponents until I got to this visualization, it wasn't until as an adult looking back, it was my struggles because I couldn't do this until I could visualize it. It turned out to be a real boost to my mathematics, and one of the reasons why I went into mathematics as a field of study was the struggles caused me to understand it in a better way. In this case, visualizing it. And if I hadn't have struggled and hadn't have been able to understand it in a better way, I might not have been attracted to math at all. But since I struggled and had to understand it in order to be able to proceed, it turned out to be like, oh wow, I really like this now. All right, now we're going to do some problems here, and we're going to write them in different formats. So the first one is this: x to the third times x to the fourth. Now, expanded out means don't use exponents. Simplified means shortest possible way to write it. Most efficient way to write it. And then rule is, what's the rule that's being demonstrated by as we went from here all the way to here? Because when you go from the problem right to the simplified answer, it demonstrates some kind of rule on this. And so I'm going to have you do the same thing as we did before. Fill out this line on your own, but type in your answers to your group chat. You might put commas in between your answers. But don't hit enter yet. And you can focus wherever you want, like if you want to just get to the simplified, or maybe put all your emphasis on the rule, or whatever you want. And then I'll give you a cue when to hit enter into your group chat. But everybody put in something. Okay, go ahead and hit enter. Discuss it in your group chats. And how are you going to write the rules, you're going to have to get creative. Okay, group 2. What do you have for expanded out?
It's Lizzie,
Hi, Lizzie.
and we had x times x times x times x times x times x times x.
Sounds like you had 7 x's.
Yes.
Okay, and I'll put that one dot right there to kind of show that that dot stayed the same. And we had like this. Okay, what do you have for simplified?
We had x to the 7th.
And what do you have for the rule?
We didn't really put down a rule. I didn't understand that, and I don't know about the other person.
Okay, all right. You did great. on these parts. The rule is getting abstract, especially when I didn't give any guidelines on how to write the rule. Does anybody have something that might be a possibility for the rule?
This is Amari. Exponent addition.
Exponent addition. Just now. So you're putting it into words, which is awesome. And if we expand on that a little bit, it's when multiplying, if bases are the same, so it only works when the two bases are exactly the same. If that was x to the third and y to the fourth, couldn't do anything. Bases are the same, add the exponent. And there's also a symbolic way to write this as a rule. And so as a rule, we could write it like this. Problem is, this will work whether that's a 3 or a 12 or any number we want. Since that can be any number we want, we put another letter there. X to the A. Now, the bottom can't be any letter. Once this letter is determined to be X, this has to be exactly the same as that. So we can't put like a Y or a Z, it has to be an X again. So that this guarantees that these two bases match. Now, what do we put as its exponent? It could be the same letter as this one, and then we could put A again. But then the rule would only work if these two had exactly the same exponent. If we put a different letter like B, then that doesn't mean that these couldn't be equal. B could be the same as A, or it could be different. Then the result is, now this is a powerful rule, you're going to get X to the A plus B. When I write real small, it tries to do something else. It thinks I'm, come on, we make it big. X to the A plus B. And it's kind of, when we get abstract and get a little disoriented at times, you might get something like z to the fifth third times z to the fifth. And you might be tempted to make 2z to something. And then this might help you realize, oh yeah, it's not that. Go back to the rule. It's just you write that same letter one time, and then you just add these two, and you get this. And it would also be especially true if these were like, you couldn't visualize them. And then this would be 8.3, like this. Add those exponents. And you don't combine these in any way, it's just write it one more time. And can't visualize it out here, but in real basic ones we can visualize it. And so the rules really help us to go directly from here to here, and to jump over this step. But it's often really instructive when you're first getting the hang of something, is that you don't skip over this step. That you do this, and either write this out or at least visualize this. Yeah, it's going to be this times, this many times, that's why it's this. And reinforce the understanding by not necessarily jumping over this, at least in your mind. Okay. And we are at a break time, so we are going to start again. At 1:30. And before I take my break, is there anybody who wants to talk to me individually or has a question on a problem on the exam? They're not sure why they got it wrong. Any any such thing? All right, I'll take my break too. Yeah, the period in the middle of the screen, I think that was multiplication. Okay, we're going to restart again. And let me put the next one. It's x to the 8th divided by x to the 2nd. So write it out in expanded form, simplified form, and then state the rule for this. And now you have an example for the rule. Just you can do it in words or you can do it in abstract symbols, however you like. And then go to the next one. X squared, change color, cubed. Write that out in expanded form, simplified form, and the rule.
Do we write these in our groups?
Yes. It might take a long time to write down everything. You might just go and just write just the rule in your group chat. Okay, go ahead and hit enter in your group chat. Talk it out for a little bit. And group 6, for this first one, x to the 8th over x squared, what's it look like expanded out?
What was that?
How did you expand out x to the 8th over x squared?
Give me a second. Let me make sure the entire group chat agreed. Just 8x's over 2x's. So like, x times x times x times x, blah blah blah.
Just separate them into two groups so it's a little easier to count.
Yeah.
Right? And then
And
simplified.
then they cancel out.
Good. Keep dividing by x and it'll become ones. And what does it simplify to?
6 or x to the power of 6.
And what's the rule?
I forget. Let me see if the group chat has it. Uh-oh.
Any ideas?
A to the power of a times b. Or,
That would go
I mean,
in the next one. Yes.
x to the power of a minus b.
All right. That's going to be
Sorry.
the right-hand side. We're going to subtract them. Yep, 8 minus 2. And the left-hand side is going to be x to the a divided by x to the b is x to the a minus b. All right. And just to go a little faster, I'm going to do this next one. I'm going to work inside the parentheses first. I'm going to only do one step at a time. Expand what's inside the parentheses, and then I'm going to expand this, and it's XX 3 times. Anything cubed is multiplied by itself 3 times. So there are 6 x's. And this is x to the a. And notice how this is different than the other one. The top one, there are 2 separate bases. There's only one base here, raised to 2 successive powers. X to the a times b. And this one, let's go back to here. Sometimes this is called power to a power multiply. When one power is raised to another power, we multiply the 2 powers. Okay. Now, we call these Rule 1 of exponent. Very creative names. Rule 2, Rule 3 of exponents. And we're going to go to some other rules of exponents. So, rules of exponents. One, whoops. Two, three, all right, now we're going to add some other ones, and we're going to do these other ones differently. We're going to create some extra rules, starting with some unusual cases. Anything, x can be any number you want, to the 0 power. And the rule for this, anything to the 0 power, now this, when I first learned this, I thought it was ridiculous, because it was just told to me, anything to the 0 power is 1, and I wasn't explained at all. My teachers just said, well, that's the rule. Anything to the 0 power is 1, and boy, did I have a hard time with this one. The reason why I had such a hard time was because I didn't even realize why it was, but I was used to an exponent, meaning how many times this thing gets multiplied by itself. The 2 shows up in an abstract way. It's how many times this gets multiplied by itself. So I kept thinking, well, x times itself 0 times should be 0, not 1. And what I failed to realize was that exponents don't mean that all the time. X to the 2.3 power does not, or 3 to the 2.3 power, does not mean 3 times itself 2.3 times. 3 to the negative 2 power does not mean 3 times itself negative 2 times. And 3 to the 0 does not mean 3 times itself 0 times. These have different definitions. I wasn't familiar with that. I kept trying to impose this idea onto this, and it kept making this not make sense to me, and I had a hard time remembering it. So, what helped me with this was, and we're going to get, right after this, we're going to get into negative exponents as well. So that's rule 5. It's going to be x to the negative a. What is a negative exponent? That's really closely connected to what is a positive, or what's a zero exponent. All right. So let's explore zero exponents and negative exponents in a way that will tell you why anything to the zero had to be 1, and why, remember when we did this before in the practice quiz. Let me slide up to one of those practice quiz problems. 2 to the negative 3 power was, you make a fraction, you bring it down to the bottom of the fraction, you change the exponent to a positive exponent, it becomes 1/8. Again, when I was taught this, I wasn't told why this was true. I was just told, oh, that's just the way it is, and it was like, I couldn't remember it. All right. So we'll get into why this is the case. Negative exponents, why do they work this way? Why did zero exponents work in the crazy way they do, where you get 1 as a result? All right. So turns out this is 1 over x to the a power. It's as if you had this, and this moves down to the bottom. So we'll get into both of these rules, why they are the way they are. All right. So the first thing is, let's ask this question. Why isn't 2 to the negative 3 equal negative 8? This was also, I remember, my reaction. When I saw negative exponents, I figured, well, 2 to the negative 3, 2 to the third would be 8. If there's a negative, it's got to be negative 8. And then when they told me, no, it's not, it's 1/8 instead, I just thought, oh, that's ridiculous. That doesn't make any sense. Why didn't they make it nice and simple like this? Turns out there was no choice. To make negative exponents meaningful, they had to make it 1/8. And I'll give you a situation that describes that. On day 0, give me $1. I will double your money every day. Excuse me. So, if you could give somebody $1 and they'd double your money every day, my God, you'd be rich really quick. Double your money every day is awesome. So this is totally unrealistic, but we're going to look for the patterns in this situation. Because the patterns here are the same kind of patterns that banks deal with every day when they give interest on money. And so we're going to take this situation. So we're going to make a table, the day number, and the dollars. And 2 to what power? All right. So we will start out, and I'll say on day 0, give me $1. Now I don't know what 2 to what that power is yet. Let's say we don't know that at this point. But if I double the money every day, then on day 1, clearly I have $2. On day 2, clearly I have $4. Day 3, I just keep doubling the previous days. I have $8. Now these things I can easily write. 2 is 2 to the first. This is 2 to the second. This is 2 to the third. Alright, now when we look for patterns, we have to try to make this a logical situation. What if I had invested my money one day earlier so that I was right on track with everybody else? One day earlier, I'll call that day -1. I'd have only had to give this guy half of $1 so that when he doubled my money, I'd be right on track with everybody else. And let's say, see, because when you double your money going in this direction, move down, you double. It has to be true that if you go in the other direction, you have to, instead of doubling it, you have to half your money. So, day -2, what amount of money must I have invested? Well, $0.25. So that one day later it doubles to half of $1. One day later it doubles to $1. I'm there with everybody else. All I needed was to invest $0.25 2 days earlier. And one day before that must have been $0.125. Because remember, to move down is to double, so move up must be taking half. So when I double 1/8, I'd get $0.25, and so on. All right. Now, let's look for the patterns. For exponents to be practical and to make sense, when you get to 0 and negative exponents, they have to work in situations like this. Patterns must be kept alive so that banks could actually use this kind of situation. And all kinds of other applications besides banking. All right, well, let's look at the pattern here. Well, what do we have? Every single time there's 2 to some power. And what's happening? As you move down, you're making these numbers go up by 1. The exponents are increasing by 1. So if you move up, they must be decreasing by 1. And then, so this must be 0. And this is reinforcing the idea 2 to the 0 is 1. You have to do such that when you go in this direction, you have to take half as much. Half as much as 2 is $1. And as we go to the next day, it's always this, whatever this number is in the first column, that's always the exponent on the 2. So 2 to the -1 must be, again, it's the opposite of doubling is halving. So you got to keep taking halves. And you don't go to negative results, you just get smaller and smaller fractions. Like this. And this would have worked had I been tripling the money. Say triples money every day. Or doubling it. Dollars and then 3 to a power. So 0, 1, 2, 3. If I invest $1, triples, so it becomes $3. That 3 triples to $9. That 9 triples to $27. Okay, and then this is 3 to the first, 3 to the second, 3 to the third. This must have been 3 to the 0. The 0 power always give you 1. And then, what must I have invested one day before so I'd be in track with everybody else? 1/3 of $1. So when it's tripled, it's $1 like everybody else. 3 to the -1 power. 1/9. 3 to the -2. 1/27th is 3 to the negative 3. All right, so there's a lot of abstraction going on here. I want to know whether I lost you or whether this makes sense. Does this add a little bit of insight to why zeros and negative exponents are not negative results? Because that's what we started with. Why isn't this equal this? Instead, it's a fraction. So if everybody give me a little feedback. Is this making sense? Is it making you more confused? How's it going? Okay, so there's some variety. Okay, and all right, so our rules are over here. Let's do another problem, and we'll go back to these rules as we do it. So notice we got 5 rules for exponents, and let's do an example. Simplify x to the 4x squared over x to the 5th 2 different ways. And so method 1. Method 2. So this one, I'm going to do like we did in this chart, where we expanded out, then simplified. So I'm going to say x squared over x to the 5th is xx over 5x's. And then I'm going to do 1-for-1 cancellation. Dividing, getting 1 each time, and I'm going to get 1 over x to the 3rd. Okay, so that's one way to do x to the squared over x to the 5th. Second way to do x to the squared over x to the 5th is to use directly one of these rules. Which rule would I use for x squared over x to the 5th? Well, that's rule 2, because when you're dividing and the bases are the same. So we're going to use rule 2 use rule 2 precisely. Okay, now, what's rule 2 say that we have to do? If we're going to use it precisely, you got to put the base down once, put the upper exponent, a subtraction sign, and then the lower exponent. So we're going to write the base down, x, the upper exponent minus the lower exponent. When we do this, we get x to the negative 3. 2 minus 5 is negative 3. Now look at, we did it 2 different ways and we got 2 different answers. But doesn't this just prove the point that a negative exponent is this? That's what a negative exponent is. That's rule 5. Negative exponent, move it to the bottom and change the exponent to be positive. move this one down to here and make it positive, and you get that. So by doing it two ways, we really are reinforcing this idea that a negative exponent had to be defined this way. If exponents are repeated multiplication, and you're getting bigger and bigger by multiplying it by more and more, the negative exponents are in a way repeated division. And we're getting, staying positive, but we're getting smaller and smaller instead of larger and larger. Repeated multiplication, positive exponent. Repeated division is a way to think of negative exponents. All right. And let's do another example. Simplify. A 2x to the minus 3 over y to the fourth. And let me give you a minute. Work on this individually, and then type your answer into your group chat. But don't hit enter quite yet. Go ahead and hit enter. Okay, group 5. What are you getting on this?
We got 2 over x to the third and y to the fourth, sorry.
2 over x to the third and y to the fourth. And who am I talking to?
Abigail.
Abigail. Okay. So, how did you get that answer, Abigail?
Because any power to the negative on the top, it goes on the denominator.
Very good. And notice she didn't move this 2. It had its own positive 1 exponent. This one moves down, and its exponent becomes positive. And that's all that we do right here. All right, thank you, Abigail. And let's do another one. B. Okay, I'm going to give you a minute on that. You don't need to type your answer into your group chat. This is kind of a longer one, but I'll give you a minute to get as far as you can on your own. Okay, 20 seconds more. Okay, there's more than one way to do this. But one of the ways that I like to do it is to get rid of the parentheses first. And to get rid of the parentheses, this is power to a power, and it's going to distribute to all the different powers. Now, this is not like, and I want to point out, it's on the practice quiz here. It's not like this one. This is two separate terms, 3 and the x, separated by plus sign. And notice the 2 doesn't distribute to both. If you distributed the 2, you get the 9 plus the x squared, and that was wrong. You had to FOIL this out. But this one that we're looking at doesn't have any plus or subtraction signs inside it. It's all one term in the inside. When it's all one term inside the parentheses, then you can go ahead and distribute the exponent to each power. So raise the 2 to the 1, and then also raise it to the negative 2. And that's power to a power multiply. The 1 and the negative 2 multiplied. X, power to a power multiply. Negative 2 times negative 2 is positive 4. Y, power to a power multiply. Negative 6. All over 12 x to negative 4. Now I might put this, that 12 really had a 1 on it. Now, I am going to, once I got rid of the parentheses, then moving, now x to the 4th and x to the negative 4th. I might be tempted to want to cancel those out. They would cancel if this was a positive 4 as well as that being a positive 4, or if they were both negative 4s. But when one's positive, one negative, they don't cancel. All the negative exponent ones move to the other side of the fraction. I'm going to be having x to the 4th. This other one that pops up here is also another x to the 4th. And then at the bottom, 2 squared times 12 to the 1st times y to the 6th. And then x to the 4th times x to the 4th. I visualize 4 x's, that's 8 x's. 2 squared is 4, 4 times 12 is 48. Y to the 6th, and there. That's as simple as I can get it. Alright, so that's using a whole lot of the properties that we have for exponents. Alright, there's something else I want to review, and that is, I had this in the practice quiz. Let's look at one of these. Example, 8 to the 2/3 power. Because it's not exactly the topic that we're on. We're on negative exponents and the rules, and we're not doing a whole lot with fractional exponents, but it's exponents, and so we should kind of review all the rules of exponents. 8 to the 2/3 power. If you'll recall, on the practice quiz today, we had the problem 9 to the 1/2. And it did not mean 9 times 1/2. The bottom number came out as the root. The top number stayed as the exponent. All right. And come down to here. All right. Let's look at this for a moment. Let's change the problem to an easier problem. If I told you 8 to the 3rd, you'd say, oh, I know what that is. That's just 8 times 8 times 8, whatever that is. Okay? Now, if I said, well, what's the opposite of raising 8 to the 3rd? Well, we know that from inverse functions, The inverse of cubing is cube rooting. So if I wanted to take this back to 8, I'd have to cube root it. Alright, so cube rooting this would get me back to 8. But 8 to the first power also is back to 8. If I divided this by 3, that's this number down here is working in the opposite direction that this one is. The upper 3 is trying to make 8 bigger into 8 times 8 times 8. The bottom 3 is trying to make it smaller back to 8. It must be cube rooting since it's going to undo what this one is doing and get you 3 divided by 3 is 1. So the top number is trying to make this thing, this 8, get larger. Turn the 8 into a 64 by squaring it. The bottom number is trying to make it smaller. It's going in the opposite direction of the 2, so it must be cube rooting it. So that's why we say take the bottom number, pull it out as the root. I think of this as the war of the exponents. He's trying to make it bigger, he's trying to make it smaller. Which one's going to dominate? Well, whichever one's bigger. The bigger one is going to make it smaller. The 3 is bigger than the 2, so it's going to make it smaller. Now, the 2 could be left as the exponent here. But it can happen in either order. And I don't want to have to take the cube root of 64. I'd have to think too hard. I'm going to delay the squared. Normally I'd put it here, but I can just say, alright, let's make it smaller first, and then make it bigger. Cube root of 8 is 2. 2 squared is 4. And notice the 8 got reduced in size to a 4 because this one won the war. The 3 is bigger than the 2, and more shrinking happened than enlarging. Alright, so that's just a quick review of fractional exponents. And then one other thing I want to go over, another example. Let's go to green. 1 divided by 1/8. Not only do I want you to get an answer, but I want you to show how you're getting your answer and why the answer is what it is, and put that into your group chat. And then in a moment I'm going to ask a group to tell me not only what their answer was, but how they got that. Okay, go ahead and hit enter into your group chat. Talk it out for a little bit. What's the answer and why? Okay, group 5. What'd you get for this? How'd you get it?
Hi. What we got was 8.
You got 8? Is this
Yeah.
Caesar or is this
Yes.
David?
It's Caesar.
Caesar. Okay. How'd you get 8, Caesar?
I'm not exactly sure.
Okay, but you know you come up with 8 somehow.
Yes.
Alright. Can anybody add a little insight as how this turns into 8 and why in the world does it turn into 8? Anybody can just turn on their microphone if you want to.
Hello, Daniel.
Daniel, okay.
So if you add, if you multiply 1/8 times 8, it equals 1.
Okay. So it's so we can kind of like check our work that way, because if you had 12 divided by 3 equals 4, this times this gives you this. 8 times 1/8 gives you 1. It checks our work. Yep, that is correct. Okay. Anything else you want to say, Daniel?
No,
Okay,
thanks.
thank you. All right, so let me also point out, just to expand on the same thing a little bit, is one way we think of 12 divided by 3 is how many times do you have to add 3 to itself to get to 12? Well, you have to add 3 to itself 4 times before you get to 12. So how many 1/8 are there in 1? Well, you have to add 1/8 to itself 8 times before you get to 1. And yet another way is we teach this. Copy, dot, flip. Copy the first, the top one, flip the second one, and then we come up with that. So we have this technique that we use that also gives it. All right. But what I'm pointing out is something really important. If 1 divided by 1/8 is 8, then look at this. 1/8 is the same as 2 to the negative 3. We saw that in that chart. Negative exponents give us. So what is this? It must be the case that we can also use this strategy of movement in this direction. If it's in the negative, if it's in the bottom, we must be able to move it up to the top. And then do this. Okay. So this gives us a little insight into why it was when we were over here that we got to not only move things down as negative exponents, but the ones that were already down moved up. So everything switches positions when they're negative exponents. All right, so the homework is 1.2, and are there any questions? All right, y'all have a great rest of your day. I'm going to stop the recording.